Hello, everybody. Thank you for waiting patiently, and thank you so much for joining this energy storage news webinar with Leclanché. I'm Andy Colthorpe, the editor of the website. I've been very privileged to oversee the development of energy storage news and write about projects, technologies, policy and regulation for the past 6 years or so. We have seen lithium-ion battery storage gradually gain acceptance in the global electricity system from the point where a few years ago we were patiently waiting to see deployments finally pass the 1 gigawatt mark. This year, in 2021, analysis firm IHS Markit has predicted that more than 10 gigawatts will be installed around the world, more than double the 4.5 gigawatts the company reported for 2020. Around half of that new capacity will be in the US, according to IHS Markit, but other regions are emerging, with the European Union's clean energy and economic recovery policies recognizing the key role of batteries, not just in electric vehicles, but also on the grid. The Asia-Pacific region looks set to accelerate over the coming years as well, and as the global megatrend towards installing higher shares of renewables continues, battery storage looks to be in a healthy position. Now, there is almost always a counterpoint to that positivity, and as stakeholders in the industry know all too well, there are still some big challenges ahead. While a system manufacturer and integrator can't necessarily directly influence policy or regulation, it can develop and make products, systems, and solutions that will address economic, technical, and logistical issues. We'll be learning today how Leclanché, a vertically integrated battery storage company, is applying years of experience and know-how to develop a solution that it claims can combat 3 of the biggest challenges facing the industry today. These are cost, complexity, and environmental footprint. So number 1, cost. Perhaps the most talked about aspect of cost is the importance of reducing the cost of batteries themselves. Research from Bloomberg NEF indicates that battery cell costs have fallen about 89% since 2010 for stationary storage and electric vehicles. That is terrific news, but it's only one side of the cost equation, and there's still a lot to think about in terms of balance of plant, interconnection, and plenty of other costs associated with battery storage projects. Number 2, complexity. Reaching mass scale with battery storage production and installation hasn't been that easy due to the need to customize system design and technologies on a project-by-project basis. Ways to reduce the complexity of these aspects of project development and execution have long been welcomed by the industry. And thirdly, last but certainly not least, environmental footprint. Again, it's often the manufacture of lithium-ion batteries that gets a lot of attention from the media when it comes to considering the environmental footprint of battery storage. But the logistics of battery storage projects also include transportation, packaging waste, and other considerations which are not insignificant when factored in. I'll leave it to Cyril and Daniel from Leclanché to offer more details on the strategies that their company has used to come up with Le Bloc, which could be a neat way to mitigate the major pain points of those 3 challenges. So, joining us today are Daniel Faure, who is VP of System Engineering, and Cyril Carpentier, who is the EMEA Region Sales and Business Development Manager with Leclanché. And also with us will be Jens Clemens, who is the project lead for battery storage and energy supply at SWB. He'll be offering a third-party view on energy storage project development, having used Leclanché's ESS solutions at a recent project in Germany. As always with our webinars, we welcome input and interaction with you, the audience. So please put your questions for the speakers into the tab on the right-hand side of your screen, and we will do our best to answer as many as possible in the Q&A section towards the end of today's session. So without further ado, over to our first speaker. Over to you, Cyril.
Hello, everyone. Thank you for the introduction, Andy. I just share my screen. I hope you can see it now.
Yeah.
Okay, so hello everyone. I'm very happy to be there and to speak today about the new approach to shorten installation and simplify logistics. I'm Cyril Carpentier, Sales and Business Developer at Leclanché. And today, what we will see in my presentation is, in our presentation, is the different challenge of energy storage that we have today. Then we will see how we can solve them through our new approach and a new solution that is called Le Bloc. And so for the last part, we will have a presentation from Jens Clemens from SWB Germany about the project HyRek. I will just start with a short introduction of Leclanché. So Leclanché is an old company, Swiss-based company. We are 280 people, so mainly in Switzerland, in Germany, in north of Europe, in USA, and India. We have 3 business units. One is transportation. The other one is specialty, that is like typically the military application. And the last one, where Daniel and myself are working, is a stationary solution where we have installed so far 130 megawatt-hour worldwide. Leclanché is known for producing battery cells, it's true. So that's why I just explained a little bit that for transportation and specialty, we typically use our own cells that we produce in our factory in Germany to make some customized battery system and rack for marine application. And for stationary, we are more working like an integrator. So it means that we focus on the sizing of project, on the business model part, and then of the integration of different components, such as battery, inverter, enclosure system. And we put on the top our own EMS to control the system. Good. So now today we are here to speak about the challenge for the battery storage system. So far, the challenge was mainly to reduce the cost of the battery cells, and we have seen that the costs have decreased a lot. But now, in order to go further, there are some new challenges that we would like to tackle with our solution. So the first one is the logistic. Logistic and installation are expensive and take too much time. The other one that we see today more and more is the battery project that have a high carbon footprint and that we need to reduce. Then what we have is the issue of maintaining the capacity over the 10, 15, 20 years of a project. How can we increase the capacity so we can keep the usable capacity over all this time? And at last but not least, we will make a focus about the safety. So let's start now with logistic and installation. And for that, let's have a look on a typical case, how we make an energy storage system. And typically, such a system based on container are made with 2 factories, one that is producing the modules and the racks system, and another one that will integrate that. So we have the first factory that will produce some empty racks that will send to another factory that will start to build a container. So an empty container with inside the empty racks that will make a project-specific protection system, project-specific cooling system. And in parallel, the factory B will produce all the modules. Everything is sent on site, and then let's say the big part of the job is starting because we need to take all the modules and put them in the empty racks on the other container. And by doing that, so it's a long operation, creating a lot of waste. Once you have done that, you still have to connect all the modules. And so it's a long operation. And at the end, you finally get your system ready to make the first commissioning, but you still need to get rid of an empty container and a lot of waste. And so by doing that, we see that it's quite complex, but at the same time, we see the second point that is the CO2 emission. So far, we focus mainly on the CO2 emission of the module production, but we see that by doing project that way, we have a lot of CO2 emission that is linked to the shipping of the empty racks, the shipping of the empty container of the modules. Once we are on site, we generate a lot of waste, that is CO2 as well. And at the end, we still have to get rid of the empty container and the waste. So as you see, this is a lot of CO2. And we wanted to change this way of working with a new approach that is our solution that is called Le Bloc. And for that, I will let my colleague Daniel Feur to present this system.
Yeah, thanks, Cyril. Hello, my name is Daniel. I'm in charge of the system design for stationary storage solutions at Leclanché, and I was the lead developer of this new Le Bloc concept. I want to give you a quick introduction of the concept we have developed. So the new approaches we've gained over the last 7 to 8 years, you can say, all kinds of different experiences for different system integration approaches on a battery storage level. Those ranging from standard shipping containers to customized shipping containers, up to concrete enclosures, existing building, and on purpose-built enclosures. And all of those, we've faced different challenges coming from the manufacturing, the logistics, the construction on site, installation, and even for operation and service and maintenance. And all those led us to come up with a new concept, which is more modular and easy scalable on a large scale. And the new concept, what we call Le Bloc, is a modular building block approach, which contains the entire BESS and its infrastructure. It is easy to, let's say, scale up, and it will also improve the logistics, the installation on time, and down the road then even the flexible augmentation and rearrangements of the blocks. As you can see on the picture, there are two different kinds of building blocks. First, we have the combi block. That's the block with the orange bar. This block contains all the necessary equipment to have a safe interconnection to the upstream components, like a battery inverter or a DC-DC converter. And then we have the green battery blocks, which contain the battery storage system. Each block contains the same interfaces on top, and we can connect them mechanically and electrically together to build larger scale systems. The combi block also contains the chiller inside, which allows you to have the temperature management of the entire system. The battery block on the next slide, as you can see right now, we have a solution containing with the LFP cells inside, has values up to 745 kilowatt hours roughly, and it contains a liquid cooled battery. And each battery block is equipped with an automatic fire detection and suppression system. We have deflagration panels on top. On both sides, we have lockable doors, which are monitored, and the entire enclosure is C5M coated. The combi block is divided into two sections. On the top, we have the the cooling equipment with the chiller and the compressor and all of that. And on the bottom, we have the necessary infrastructure that's needed for a battery system, like fuses, disconnectors, and all the energy management hardware, plus isolation monitoring and additional equipment that's maybe needed for a project installation. The unique feature of the block concept is its mechanical setup. So each of those blocks pretty much represents or resembles a ISO shipping container, which has this ISO corner in each end. This allows us to connect up to 4 blocks together, which then create a 20-foot shipping container. So we can handle those blocks when we connect them together as they are standard shipping containers. Each block comes pre-equipped, pre-assembled, pre-wired, and pre-tested, and can be then shipped as it is without the need of additional enclosure directly to the site. And this is a huge improvement in terms of the logistic expenses you have, also reduces the carbon footprint, and massively reduces the installation times on site. As you can see on the top, we have this interconnection section, as we call it, which it's identical on each block. And in each connection section, we have the DC high voltage connections, the auxiliary connections, and the liquid cooling connections. If you can go on the next slide, please, Cyril. And then you can see here, we just put them together. And then you see in the site arrangement as an example on the next slide, which is a really dense solution, as you can see. You see a combi block on each end of the bank and the battery blocks in between, all connected on top together. So we just need to bring the system on site, crane them down on a pre-prepared concrete foundation, do the missing interconnections between the battery blocks, and wire the entire system to the battery inverter in this case, and we're ready for commissioning. You can also see each block has corner fittings to be craneable, but also the slots on the bottom to be used with the forklift. So if we want to rearrange blocks or have to replace blocks, that can easily be done with cranes or with forklifts on site. As Cyril mentioned in the beginning, we didn't only want to improve the concept in terms of installation and improvements in servicing and maintenance. We wanted also to bring the system safety onto a next level, coming from not only from system level safety, but also on human safety. And I think the biggest improvement is clearly the concept itself with this portionate building blocks. That means we don't have large battery room installations anymore. Each battery block in itself is a closed block, which has a high fire resistance rating. That means in an event of a fire, for example, there's an unlikely possibility that we have a propagation from rack to rack, since the systems itself is already enclosed. Additionally, it's an unmanned enclosure. That means you can't typically enter the battery block, which improves also the safety level on human aspects. Additionally, we have a fire detection and suppression system in each battery block, containing of gas detection and combined smoke and heat detection, and an automatic suppression system with an aerosol. Over the entire battery system, coming from the combiner block up to the battery blocks, we have an emergency stop function, which is triggered by anomalies detected by the EMS, or if, let's say, the emergency stop function is triggered by an emergency button by first responders or operationals, or if devices like the ground fault detection or other stuff triggers the e-stop function. We have isolation monitoring equipped in the combi block, and we have a deflagration panel on each battery block, which will direct any kind of overpressure inside upwards to also improve human safety on site. This all is under certification and is aiming to be applicable for both major markets. That means IEC and North American market. We have a UL 9540A approved battery system inside, UN 38.3 approvement for the transport of the entire block pre-assembled, and additionally we have safety certifications on IEC level, plus the NFPA 855 and 68 for the risk mitigation and deflagration for each block. This was a quick introduction of the block. I give back now to Cyril to proceed with the rest of the presentation.
Thank you, Daniel. So thank you for the intro, so the explanation of the block. Now let's see how it's changed now for the logistic of the project. Now the logistic, the transportation, the installation is way easier. Everything is leaving the same, let's say, factory. Everything is shipped as a 20-feet container, and once it arrives on site, you just put them on site, and that's it. You have to connect on the top, but I mean it's not a big deal that. And as you see, we use a standard 20-feet container. You don't need trenches. You don't have to make cabling on site. You don't have empty container to send back, and there's no specific combiner with a DC protection to add and connect on the site. We've made some simulation on different projects, and we came to the conclusion that we are able to reduce up to 50% the time for the installation, and in some projects up to 40% cost reduction for the transportation and installation. So it's a really big improvement. So I expect some questions to say, yes, there are some other solutions on the market that are modular like that. It's true, we are not the only one. We are just, let's say, following a general trend to make some modular system. But we just wanted to explain the difference maybe with some system we see today on the market. There's still this big advantage that everything is leaving the same factory and is shipped within the transportation container. But once you arrive on site, you still have some operation to do. So you still need to take the rack and put them on a concrete foundation. You still, it will still generate some waste by doing that. Once you have done that, you need to install a specific combiner, let's say combiner box with protection inside. You still have to to cable all these racks together with the combiner box, and at the end you still need to get rid of the empty container and the waste that you got. If it's not problematic, let's say if you are in the middle of US or Europe, it begins to be a challenge when you are in a remote area on an island. And so that's why if we want to have a kind of small synthesis, we see I've made a synthesis to compare the different solutions for the transportation point of view and installation on site. We see that for the standard container approach so far, so we need to transport the rack, the module, and enclosure separately. So it's all-time cost and CO2 emission linked to that. Once you arrive on site, you need to unload the battery module from a transportation container. You need to mount that within the other container. You don't have to cable the battery on site because it's in already the pre-wired container, but you have some waste to manage, an empty container to send back. So cost and CO2 all the time. We see this new solution today on the market as well. It's a big improvement for the transportation because you have a single transportation, so single cost and single source of emission for the CO2, but you still have to unload the rack from the transportation container. You have some, depending on the technology, sometimes you need to make some cabling on site for the battery rack, and you still have the waste to manage, and you still have the transportation container to send back. With the block, what is good is you have the single transportation, but you have only the single transportation. You don't have nothing else here to do. So this is already a step beyond in order to improve and the logistic and installation reduce the cost and CO2 emission. Good. So the last part we wanted to address is when we need to maintain a certain capacity over the years or to reconfigure a project. Now it can be easily done through this modular approach. You can, if you have a system like that with 4 PCS and 4 banks of blocks, you can easily reconfigure that by putting the blocks that have the same edging with the other one, and then you have an empty PCS, empty input, where you can put in 10 years from now, you can put some new battery, new technology that will be way more efficient and way more cheaper. with and you can make this augmentation. So what is important, you do that, it's only playing like Lego, and you just have to put them and connect on the top. You don't need to make recoupling from top. Good. So as you see, we were able to tackle the different new challenges that you have today in the new for the battery energy storage systems. And as a conclusion, we just wanted to have on one slide to show that from the design, the logistic, the installation, the operation and end of life, we reduce all time the cost and the CO2 emission at each step with this this new concept. Until the end of life, where it will be very easy now to at the end of life just take the block and ship them to a brick back point, sorry, at the end of life. And as a just as a conclusion, I wanted to say that if you go on our website, you have the possibility to play a little bit and see how big and how it looks like to have a configuration with different power and battery capacity. You just have to go on leclanché.com/leblock, and so you will have at the end of the web page a configurator that will allow you to make some simulation and contact us if you have any question. And that's it for my presentation and presentation of Daniel.
Excellent. Thank you very much, Cyril. Thanks a lot, Daniel, as well. And yeah, I kind of look forward to having a bit of a go at playing at the configurator myself. But yeah, so great presentation, and obviously it's an interesting new concept there. We've already got lots and lots of questions coming in, so hopefully we'll be able to get to tackle as many of those as possible. But yeah, next up, joining us now is Jens Clemens, who is with SWB. Jens is going to be talking you through Project HyRek, which is the hybrid regulation power plant, combining heat and battery power plant to provide frequency containment reserve in the Hasted district, of Bremen, and making efficient use of an interface between the power grid and a district heating system. Jens, over to you, please.
Thank you, Andy. Yeah, my name is Jens Clemens. I'm from the SWB services. I wanted to present you the HyRek system that we provided with Leclanché batteries. So in the first slides, I wanted to present you the company SWB. So SWB is an energy provider in the northwest of Germany with 2,500 employment. You see here we split it in two divisions. One division is the pure energy and drinking water provider with a sales team and a grid operator. And the second division is the technical services devices that we provide energy services, street lighting, gas handling, and also waste management. Yeah, I'm in the services division. We have divided this also in two parts of division. In the first time, we are in consulting of energy supply, and in this we do energy concepts, create energy for customer, and do also energy supply in all kind of energies. We also operate on energy systems, and in the second division we deliver parts. So beginning from combined heat and power systems to the storage division, and the PV generator. In 2019, we commissioned our HyRek. HyRek is short for hybrid Regelkraftwerk in German. So a combination of battery system and restricted heat. For this, we provided here in Bremen a 15 megawatt FCR system with 15 megawatt of power to heat section. and this is divided in 3 units. So you can see here, this is 1 unit in the middle with the battery. Parallel to this, the heat systems, and on the left and right side, the inverter unit with the transformer on site. So with this system is installed in 21 containers with a huge, great place here.
Jens,
Yeah.
I'm really sorry to interrupt there. We had someone from the audience asking if you could maybe speak up a little bit louder. They're having a little bit of trouble hearing you, I think.
Okay, I try to.
Maybe.
I put the microphone near to my mouth, so that, yeah. So
Excellent, thank you.
After the installation, we did a lesson and learned to the HyRek system and see, okay, we had a huge installation and commissioning times of 8 months together. We installed many cables together, 26 kilometers inner cable connections and 5 kilometers piping ways. We needed 21 fundaments and 3 big fire resistant walls on the system. So with a large scale on the fundamental footprint, together we needed 20 trucks, 6 trains, and 3 Merlos. We had no chance to do a pre-commissioning in the factory, and we did all the tests on site with a high amount on manpower. And you see, with 15 kilowatt per square meters, a high energy destination. So with this impact, we had to go on a better impact to create a small compact systems that is easier to install with short cable rails and the pre-testing in our factory itself. So with this, we created a 3 megawatt unit for FCR. You can see here on the right side the inverter system, in the middle the mid voltage connection with the transformer and the switchgear, and on this side the the battery systems with the HVAC systems on in, and the fire detection system also in, the heater in the middle, and a second container to get then the 3 megawatt systems together. So and the connections between heater and inverter systems was then set to not on cableway, we get here on copper bars. Here we can easily slow down then the amount of basements, have all this compact in 3 containers, have the heater inside, and also 2.5 megawatt hours on battery capacity. But this through the impact that we have all this in the 40 feet containers, only limited to 2.5 megawatt hours. It's then a fast installation and fast connection times, because we only have to do the mid voltage connections on the systems and the bus bar connection to the heater. So with this system we have a big impact on then installation time and time on site. The manpower stays still high because the installation of the batteries is still there. We rise up the energy destiny to 70.8 kV per square meters. So, and with the implementation of the new LeBlock system, we can go through higher and better installation on site too. So you see here still the part in the container with the inverter and control system, then 2 transformers and a switchgear and the heater with all pump equipment inside the second container. But we go away from the 40 feet container to a 9 meters length containers, and one Le Bloc system then separate. With this, we only have to do the connections with the bus bar to the Le Bloc, and the connections to with the mid voltage side, and can decrease also the installation time to 2 days. The connection times scales down to 5 days. We delete the battery installation time and the high amount of manpower on site. We can pre-test this in the factory and have a high energy density with 18.6 kV square meters. So here I give you a footprint of a 15 megawatt site. So the combination of heat and inverter system with mid voltage connection on the right side, in the middle the Le Bloc, and on the other side then a second system, so that we have a smaller footprint and a smaller installation time here. When we now make a comparison between the HyRek here in Bremen and the new HyRek system, you see we scale down the overall installation time to the half of the time. We can go to a third of the time on the pure installation time, and the number of crane retaining on site we scale down also to one third. Yeah, the amount of containers we still 21 in the HyRek here, together 12 containers and one Le Bloc systems. Yeah, the scale down is there with 14% down. But the big benefit in this is the huge amounts of cable we have here in Bremen, and this we scale down from 26 kilometers to 6 kilometers. And the huge installation time for the cables in the earth from 4 months to 4 weeks, so a huge amount. And the trucks we can also scale down. The next big benefit is that we can totally erase the firewalls through the separate pack of the Le Bloc in the system, and the big advantage that this is self-protected. Yeah, this to the end of my presentation.
Terrific. Thank you very much, Jens. And yeah, really illuminating and kind of taking what Cyril and Daniel are talking about and kind of applying that directly to a real life example, really, I guess. So, guys, I hope you're ready. We have lots and lots of questions from the audience. As I say, we probably won't be able to tackle all of them, but we'll see how many we can get to. So, yeah, in no particular order, I guess we could start with, there's a question here that I found quite interesting from Nisha Kondola, who asked, have your batteries been used in grid services and response, which I presume means frequency response? And I'm going to take a wild guess and say that the answer is very much yes, but do you guys just want to explain briefly the sorts of applications and maybe the types of projects that you might expect to see Le Bloc being used in the coming years? Daniel, I don't know if you want to maybe take that one.
Yeah, sure. Thanks, Andy. Yeah, so as you see by the concept, it's clearly aiming on larger scale installations. We as Leclanché have two mostly targeted market for us. That is the microgrid solar integration market, and of course the ancillary services market, which we also have quite a lot of experience in. The block is, of course, developed and aiming for both of those markets. So we have, let's say, even a third one, which would be the support of the EV charging infrastructure as a third major market for us. For the solar integration microgrid, we are developing currently projects where the batteries are AC connected as well, directly DC connected to the PV within the solar plants. And for ancillary services, yes, the LFP technology we are using is capable to do frequency regulation.
Right, and I saw there was a question there on DC coupling, and you just mentioned that briefly, but that's kind of a market that's starting to really pick up, particularly in the US solar plus storage space, really, I guess. And so you're saying that the product is adaptable to that as well, I guess.
Correct.
When we started the development of the blocks, we also wanted to use the block, the enclosure and the interfaces, also for additional necessary equipment which is needed for different sites. So if we have, for example, the EV chargers, we'd want to try to also include necessary hardware in there. And for solar integrated solutions, we also came up with a concept where one of the blocks acts as the DC integration. So we can directly wire the PV strings to an additional block. And from there, we connect it directly to the DC-DC converters and the battery system.
Right. I mean, I guess the EV thing is going to be important, well, very much important worldwide, but especially in Europe for stationary storage. I think a lot of people are talking about, the importance of batteries for kind of buffering the grid against the increased electricity demand from electric vehicles, I guess.
Yes, correct. Yeah. So the two main markets is to reduce, or the two main advantages is to reduce grid connection costs by having the batteries trickle charged and use them the discharge capability to provide power to the chargers, and even to shift the peak hours when the most cars approach the chargers and electricity prices is the highest, to shift this to have the batteries charged in low tariff hours of the day, and then have sufficient capacity on site to supply the chargers.
Okay, absolutely. So there's a good question here from Arsalan Bayatmaku. Thanks for your question, Arsalan. So he's asking, what are the important factors for reinstalling and changing the location of the battery energy storage system? For instance, if we want to change the place again and relocate the BESS to a new place, what sort of considerations come into play with that?
Not much. I mean, same as for the installation itself. So each block is transportable. So you just have to disconnect them mechanically and electrically, and then you can pretty much transport them as they are, relocate them, and reestablish the electrical connections, and then you're good to go.
Okay. So we've got an equipment. So what you're saying is pretty simple, really. Hopefully, by the sounds of it. So there's an equipment question here from Simon Valdivia, who's asking. He wasn't sure if it's that you guys provide the PCS, the power conversion system, as well. So he noted that you provide the energy management solution, system solution, but it wasn't so clear on the PCS side of things. Can you just talk us through that, how you're looking at that, and whether that has an impact on structuring of warranties if and when PCS is provided by a third party, if it is?
I can answer to the first part of the question to say that we work as an integrator. So it means that we design, we supply, and we deliver a complete system based on the PCS, so inverter, transformer, and switchgear, plus the Le Bloc system, and everything is controlled by the EMS on the top, our EMS that will speak with the battery and the inverter, typically. Regarding the warranty topic, So far, the warranty, I mean, once we deliver everything, so it's the warranty, we cover that. Then after, it's product specific. We need to see if this is something we can do or not regarding the battery, the warranty for the PCS.
Yeah, so we provide turnkey solutions. That means we provide the PCS, the battery storage system, and the necessary software that controls everything. But LeBlanc is a concept, an agnostic concept, which allows you to use that PCS that is mostly suited for this project. Of course, we have some PCS vendors we preferably work together, especially since the blocks have some certain aspects in terms of voltage range and power. But the concept itself is agnostic, which should be able to work with different kinds of battery technologies and also different kinds of PCSs, or in the other scenario, which I said, directly with maybe DC-DC controllers for EV charging or solar integration. But we as Leclanché, we provide turnkey solutions.
Okay, and I guess on a related theme to that, there's a question here from Dishin Sonny, who would like to know how you customize the solution in terms of project-specific battery sizes required, and I think more pertinent to what you're talking about just then, to different PCS voltage ranges.
Yeah, as I said, the battery blocks we currently use have LFP technology inside and a fixed voltage range, and therefore we have, let's say, a panel of battery inverter suppliers we work together with.
We adapt, we play with the modularity of the block, like a Lego block, but so we won't change to this, let's say, voltage value to adapt to some PCS.
Right, okay. And I think there's a question that several people asked, but how many battery sections can be connected to one combi? So the product basically works in that you have battery blocks, you can have several of those, and then a combi block per sort of row of battery blocks. So kind of how many battery sections can be connected to each combi section? And I guess, you know, what sort of output and capacities of storage does that give people the opportunity to sort of play with, I guess?
Yeah, I mean, that depends on the use case. So of course the power, the applicable power, and of course heat dissipation. We can connect up to 7-8 blocks per combi block, and then we can, you know, scale up the system needs as much as it's needed. It's just then the amount of combi blocks that has to be put into the system. Yeah.
And it's 750 kilowatt hours per battery block, right?
Correct.
And yeah, so personally, my maths isn't quite good enough to quickly think about how many that means, but I'm sure people watching will be able to sort that out themselves as well. So I was just wondering, this is maybe a little bit of a future question, but Spencer Flotman was asking, how easy is it to transition to new chemistries on the cell level as battery advances continue to propagate? Now, I'm kind of guessing that, you know, once you've bought batteries and put them in, you're not going to want to replace them until they've done a fair bit of work anyway, because that would just, you know, cost you a lot of money. But yeah, I mean, in terms of kind of upgrading kind of later on, what are sort of the strategies you guys have been thinking about for that?
Yeah, so clearly we don't want to, the enclosure is designed to be adaptable for all kinds of battery. Our focus right now is to really have a dense system, a dense and safe system, which also operates in the, let's say, state-of-art voltage ranges. So if we have a new vendor which has a liquid-cooled battery, which has the necessary UL 95 certifications that allow us to integrate it, and is liquid-cooled, then the integration is easy, you know. For other technologies, other cooling methods, it would be more challenging, but we're also working on that as well. But if you fulfill those aspects, the integration would be fairly easy.
Okay. And I mean, Jens, I'm just wondering, in terms of, from your point of view on the HyRek project, I mean, you gave us some of the numbers, but can you just maybe give us your thoughts on how you feel, how differently you feel the project kind of would have gone, and, how quickly it could have been done, and whether you kind of would be looking to do similar sorts of things elsewhere, really? Where's SWB sort of energy storage activities at the moment?
So the SWB activities is to create a customized system. So we installed in the meantime an emergency dicer system. So for replacement, we working on several parts of battery storage systems, far away from the restricted heat, and not on the FCR mode, only on the high power mode and peak shaving mode, but on these times we fully are in the market. So the FCR is in Germany not so high requested anymore, cause the market is going down here. But I see the big benefit of the HyRek. Cause we work on another SoC with this system. So the normal BAS working about around 50% of the SoC, we working on 75%, and use then the heater for a battery expander, and this is a big benefit that we can scale down the battery amounts. Yeah. Not so good to hear for Leclanché, but the systems can really save money here. And with the LeBlock, we have the big chance to go on all the things that comes with the fire restriction rules, and have here its separate reason and separate area with the batteries and the good protection of the LeBlock here. And that's for me the big benefit to have an FCR system. I saw in the question in the chat that were asking that if we can work also as a replacement of a diesel generator. In the end, we can. It demands here on the power of that is needed for the system, and then the amounts of battery we need. So the PCS systems from the guy from AEG are fully black start capable, and we have a minimal switching time here of milliseconds in a blackout scenario that we can provide then with this systems and energy emergency supply.
Right. Okay. So it's kind of, these sorts of solutions are changing quite quickly what you guys are able to do as project company, really, I guess. Okay, so there's some questions here on, and I think this is becoming a bigger question, and maybe it's one more for the project developers than for the technology providers, although everyone in the value chain will have to take responsibility for it. But so there's a couple of people here asking about the decommissioning, recycling, and other end-of-life management potential. So I don't know if maybe we'll start with Jens, your view on how you kind of are considering, and it's quite early in the development of grid scale energy storage to be thinking about, really. But the decommissioning and end of life management for projects, is that something you're already kind of really factoring in, and what challenges have you found on that? And then maybe after that we can get a view from Cyril and Daniel on how Leclanché kind of look at these things.
So for me, the question is a little bit far away because, yeah, you know, we commissioned the system in 2019, so we are only 2 years in operation. So we have in the calculation 18 years in front, but we have also the view on the use of second life batteries with the systems. We created a design study for together with a big car developer in German to look what we need to have this battery in big storage areas and create a system there. But in the end, after the second use, yeah, we are not fully in the recycle of batteries here and there. We have our partners like Leclanché, AG, etc. on the markets to have this.
Right, of course, yeah. I mean, obviously it's early days, but you know, as one question's come in about the EU regulations, which you know are gradually coming in, really, I guess, for recycled content and what have you. So, yeah, Daniel and Cyril, from your point of view, with the decommissioning and end of life management of Le Bloc, obviously, you know, for anyone bringing out a new product, it's kind of a little bit heartbreaking to think about what's going to happen to it at the end. But yeah, how are you sort of you know taking care of that, and how do you think your partners will take care of that?
Okay. So to answer to that one, from the beginning, we wanted to tackle this challenge as for the installation. Because today, to understand a little bit, once you have a project in a container, you still have a lot of operation at the end of life because you cannot transport the container. It's too heavy that way. It's not made for that. So you need to disconnect all the module, unmount all the module, put that in a specific packaging, and send that to a brick back point that is maybe not existing yet. So we wanted to create from the beginning something that will allow us in 10, 15 years from now to bring very easily to simplify all these logistic and transportation topics to go to the recycling facilities. And so that's why what we have done for the installation, we can do that as well at the end for the recycling. Maybe today there are still some some bring back points missing in the different location where we install the energy storage, but we know that 10-15 years from now it will be a lot of new recycling factory everywhere to manage all these electrical vehicles. So at least we are sure that with Le Bloc it will be super easy to bring that to this location.
Right, sure. Daniel, anything to add from the system design perspective there, I guess?
Oh, yeah, sorry. As Cyril mentioned, was the biggest aspect we think is that we can use the block enclosures directly as the vessel or the container to bring the batteries back to its origin, to have a recycling aspect of it. And we as battery manufacturer on our own, we know anyway the regulations we have to fulfill to take back our batteries. And unfortunately, the processes are not that well developed, but we hope in the future that we will have different forms and methods to refurbish batteries and bring them back into a second life, or even have a process to retain the raw materials inside.
Absolutely, yeah. And I mean, we are seeing, you know, almost every week there's starting to be kind of announcements, and as with a lot of the lithium-ion battery stuff, it seems to start with electric vehicles, but you know, just today we were writing about a company that's really stepping up their efforts in North America and recycling stationary energy storage system batteries. So yeah, so it's an exciting space, and although I guess, you know, hopefully these things will be a good few years in the field before those things come into consideration. It obviously is a consideration. Yeah, I mean, there's a question here actually, which is slightly different to that from Richard Ottner. So Richard, thank you for your question. But so what happens if, you know, a single block and installed location has a problem and fails? What's the sort of process for, I guess, for fault finding and replacing a single block, and then, you know, I guess the disposal and early end of life of that particular block?
Yeah, in this scenario, I mean, the connections are running in parallel. So if there is a malfunction in one, the bank could you know, continue its operation. The single block then just needs to be, you know, replaced or taken out of the bank, and the other blocks can be reconnected. And then we could simply replace the block as it is with a new block and continue operation.
So it is really, yeah, I mean, it's taking that standardizing all the way through every level of the project, really, I guess, isn't it? Yeah. Sure. Okay, I think we've pretty much run out of time for today, but one last quick question, if we may. And Serge Peters wasn't sure if there's a weight increase due to the use of steel in the block, and does that have an increase in CO2 and cost of transport? And it didn't seem that way to me from the presentation, but do you want to just maybe quickly talk about sort of materials used and, you know, whether that has an impact on the weight and so on?
Yeah, if you want to transport ISO containers, especially as we assemble 4 blocks together, there's a maximum weight limitation on global regulations. So we have designed the block concept to be as rigid and robust as possible, so you can handle this arrangement as it is a 20-foot standard containers, and to be underneath that maximum weight limitation, which is currently 13.4 tons. 30.4 tons. Yeah, so there's no, I don't know, anything more than that, yeah.
Excellent. Okay, well, I think that's pretty much all we've got time for today. We will be posting this webinar on the on-demand section of the website. A short while after that, a few weeks later, it will end up on our YouTube channel, I think. But in the meantime, if you want to watch it on demand, and then obviously you can follow up with the guys from Leclanché or with Jens from SWB. If you're quick, you can take down their email addresses now and get in touch if you've got anything else you want to talk to them about. But I think for now, just want to thank everyone so much for participating. Many thanks to Jens for joining us, and to you, Cyril, and to you, Daniel, for your excellent presentations. Thank you very much, and we look forward to hearing more when we start seeing Leclanché Le blocks out in the field in the months to come.
Thanks, Andy.
Thank you, everyone.
Thanks, everyone. Goodbye.
Thanks, everyone. Thanks, Andy.